All right, so here's a review from 1-1, and I can also do a review of 1-2 if you want to redo this quiz. So here's a review. And so 1-1 introduced the idea of a limit, and the limit has to do with the word approaching. And it's the approaching y value as x approaches a number. And the next concept is the concept of continuous. And a function is considered to be continuous if the function value equals the limit value. Here we'll say it at a. So if the function value equals the limit value at any x value, then this is what continuity means. So the function value and the limit value are equal to each other at that x value. And if a function's continuous, it's really easy to evaluate a limit. So if we're trying to evaluate a limit and I know it is continuous, so x squared take away 2x is continuous at 1, then all I have to do is direct substitution to answer it. Now, what happens? Here's the situation. At 2, it is not continuous. And when I plug 2 into the top, it gives me an answer that's not 0. So it's not indeterminate. So this is 3 over 0. This means the limit doesn't exist. If I look at this situation, here we're evaluating a limit. At positive 3, it's continuous. It's not undefined. So if I plug 3 in, I get the answer 0 over 6. And recognize that answer is 0, while this answer does not exist. And then we get into the idea of removable or non-removable. So it's removable if the limit exists at that discontinuity. So if the limit exists at a discontinuity, it's removable. Non-removable means the limit does not exist. So one, the limit exists. The other limit does not exist. So if I look here, here I have a limit. If I plug 5 in, it is undefined. But yet, if I look above, we can remove it and the limit exists. So because the limit exists, this is an example of a removable discontinuity. If I do one right beside it, here, when I plug 1 in, it's undefined, and there's no way to remove it. So here the limit does not exist, and this is a non-removable. So where is that? This one's at x equals 1, and this is non-removable. This one is at x equals 5. And this one is removable because the limit exists. This one's non-removable because it doesn't exist. All right. Now, the next one was 1-2. And in 1-2, we talked about what does it mean to have something be indeterminate. So it could be, there are different forms of indeterminate, but this is really the one we're looking at, which is 0 over 0. So if we have a situation of a limit, like that, -4. If I have a situation, so if I plug in -4, this is 0. But if I plug -4 on the top, it's also 0. So this is indeterminate, which means it may or may not exist. So at this step, I can factor the numerator. So it's a difference of squares. And then it's removable, right? And then once you do that, you can plug -4 in and then be able to answer it. So when something's indeterminate, we could have the ability to factor and do that. Let me give you another example of that. If I plug 4 into the numerator and 4 into the denominator, it would be 0 over 0, indeterminate. So if I factor the numerator, I want to see if it's removable or not. So it's negative 4 and positive 3. So I want to see if what's undefined, that discontinuity, is it removable? And then I can plug 4 in and get my answer. You could also get a radical, and you might have to use the conjugate to do that. So here's an example of that. So here we have a situation of a radical. If I plug 9 in, the square root of 9 take away square root of 9 take away 3 is 0. 9 take away 9 is 0. I'd have to use what's called the conjugate. So you would add, so top and bottom, and then you would multiply it out. So root x times, and make sure you remember the limit notation. So root x times root x, negative 3 times 3, x times this. I'm only going to put them beside each other. So x minus 9 and root x plus 3, I'm not going to multiply it out. Notice the x subtract 9 is removable. So I can now plug 9 in to get my answer. And the square root of 9 is 3, and then 3 plus 3 is 6. And so there's another algebraic way to be able to remove something so I can evaluate a limit. All right, the second part was the intermediate value theorem. So the intermediate value theorem talked about the idea of continuity in a function. So if I give you a function and I give you an interval, does a c value exist in this situation that would give you the answer 2? So the intermediate value theorem says if you find the first y value, so plug in. If you find the second y value, plug in. So 3 squared take away 3. Does this y value, is it in the middle? Is it intermediate there between the two values? And it does. So because it's in between 0 and 6, there is a c value that exists. Now how do I find that c value? Is I take the function, make it equal to the y value I was given, and then I solve it. So in this case, I'm going to make it equal to 0. I'm going to factor it. Now we got to be careful here. So when I solve it, so I factored it, positive 2 and negative 1, the interval goes from 0 to 3. So I'm going to cross out negative 1 because it's not in the interval. And so at what c value does it give me that answer that fits this? And the answer is 2. All right. Mr. G Math over and out. Good luck on the quiz.